Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Syarimi Bezos. Kita akan discuss tentang troubleshooting of gas chromatography GC. Ini secara apa? Pengenalan. Ini ada ini gas cylinder. Peta ni mesin GC. Dia akan detector dan komputer. Biasa gas yang kita gunakan nitrogen atau helium. Kita akan pergi semua ke kolom. Daripada sini kita akan inject sampel kita. Yang penting sampel tu mesti dalam bentuk polyurethane compound organic compound. Maksudnya sampel tu mesti dalam bentuk gas lah. Jadi sebab tu ada macam inject ni supaya sampel tu akan jadi gas. Ada boleh carry daripada kolom ni. Lepas tu baru ke detector. Detector ni dia akan ada waste lah. Maksudnya dia akan buang ke komputer. The common problem in gas chromatography biasanya ada lima apabila opaque resolution, low signal, baseline noise or drift, acoustic, retention time shift. The resolution ni, the peak ni macam ni. Ada dua peak lah. Patut dekat sini. Biasanya dia akan straight. Ni kalau ikut daripada apa yang kita tahu, kita select secara nipis. Kita kena choose temperature secara nipis. Dan column dimension. Dengan kolom pun sama. Mungkin diameter kecil sama panjang. Dia mungkin akan lagi cantik kat resolution dia. For efficiency, kita kena optimize carry gas linear versatility and GC over temperature. Kita kena adjust temperature lah. Mungkin low sikit, low kan dia mungkin lagi okey. Kita akan cuba sample overload. Kita kena adjust sample concentration ataupun amount untuk yang dalam kolom tu. Incorrect analytical condition use. Ini yang kita kena verify temperature program, flow rate dan color parameter. Biasa patternnya tiga ni lah, temperature, color parameter ataupun ni secara nipis. Ni kita ada sedikit video dan kita dengar daripada Dr.
All right, we have a great GC question that came in, and that is, how do you improve resolution in gas chromatography? So, big picture question, it's a great question because resolution means the space in between the peaks. Remember, chromatography is a separation tool. Step one is to separate. If we can't separate, then we don't go on to step two. We cannot quantify, we cannot identify. So separation or resolution is the most important thing in chromatography. Unfortunately, it's also a fairly complicated concept, like what causes resolution? What do we need to get resolution? So it turns out, I give this entire 1 hour talk on resolution. I think it's the most powerful talk I give, but let me give you sort of the synopsis of it. In order to get resolution in GC, there's three things you need. I'll give you the technical terms. You need the right capacity factor, you need the correct selectivity, and you need the correct efficiency. So now let me explain what that means. The first one, capacity factor, means you have to let the analytes interact with the stationary phase, right? No interaction, no separation. So the capacity factor is all about the temperature. You need to lower the temperature in your GC enough to make sure the analytes interact with the column. So we have a rule that says capacity factor should be between 1 and 5. What that means is the first peak should come off twice the time of the solvent front, of the T0. So again, what we're getting at here is we need to leave the analytes in the stationary phase long enough to get a separation, and that means we need to lower the temperature enough for them to interact. So general rule of thumb, we drop the temperature by 25 degrees, we double the capacity factor. That's a rule of thumb. So step one, make sure you're using the right temperature. We can tell if it's the right temperature by how close it's coming off to your solvent front. So if this is the solvent front, and here's my peaks of interest, the further we get from T0, the solvent front, the better the separation is. The closer to T0, the worse the separation, and at T0, by definition, we get nothing. So rule number one, move these peaks away from T0. We do that with the temperature. Lower the temperature to make sure they're retained. So the next thing, so that's the capacity factor. The second term is called selectivity. Selectivity is the most complicated term, but let me put your minds at ease. There's a really simple way to address it. Selectivity means, do we have the right chemistry? Do I have the right interaction between the stationary phase and the analyte to tell the difference? Can the stationary phase differentiate between my molecules? So that's a chemistry question. So my biggest piece of advice there is let's either look in a catalog to find the right selectivity, the right stationary phase, or let's just take a guess and let's use a stationary phase that works for most people. That would be a DB5. So 5% phenyl, 95% methyl. Every column company made it's the go-to column in GC. So that's sort of a way to address selectivity. That alpha term tells us if you have the right stationary phase. If alpha is 1.0, means you got nothing. Your stationary phase is absolutely wrong. So we want to choose a stationary phase that gives us a better alpha. Again, easy way to start, try a DB5 or look in a column catalog. So that's the selectivity term. Final term is efficiency. Efficiency is a measure of the skinniness of the peak. So if I have two fat peaks that are coming off right next to each other, let's say these peaks are 5 minutes wide and a minute apart, well, that's terrible. If I can make the peaks 10 seconds wide and a minute apart, that's fantastic. So the question is, how do I make my peaks skinnier? So efficiency is a function of what I say the column dimensions. So to get more efficiency, which will lead to more resolution, you can use a longer column. Double the column length, you'll double your efficiency. Resolution goes up by the square root of 2, so double column length, you get 40% more resolution guaranteed. So double column length, 40% improvement in the resolution. It takes longer though, right? It takes twice as long. Second thing we could do, smaller diameter. If we decrease the diameter of the column, we increase the efficiency, peaks are skinnier, peaks are taller, better separation. Along with that, we decrease the film thickness. So by doing that, we also make the peak skinnier. So the way I remember this is in chromatography, I want tall, skinny peaks. Tall, skinny peaks come from a tall, skinny column. Long column, small diameter, thin film. So my go-to column, 30 meter, 0.25, 0.25. That is a fantastic column. You're talking about 200,000 theoretical plates, a great column to do great separations. So, in a nutshell, there's three things that affect resolution in chromatography. The first term is a function of temperature, lower the temperature to get better separation. Second term is selectivity, choose the right stationary phase. Third term is column dimensions, choose long column, small diameter, thin film, and operate it at the proper flow rate. Those things will improve resolution, hands down, guaranteed in all GC separations. So hopefully that helped out. Come back to Axion for more solutions to your problems.
Okay. Itu aja. Apa yang kata tadi ada 3 juga sama macam kita bincang tadi. Low temperature, adjust temperature. Lepas tu choose stationary base dengan column. Okay. Terima kasih.